All right. Well, today we're going to continue with sequencing. We briefly introduced routines last week, and there's a lot more to talk about. It's a really useful class. It comes up all the time, has kind of multiple purposes, but the general purpose of routine is to structure actions in time. So we have booted the server already here, and using the resolve relative technique from last week, I'm loading in 2 samples, prayer bowl and PVC. I don't know if we're going to use both of them. We might just use one or the other. And then this is the synth from last week. I know it looks big, but we sort of went through it all last week. We play a file, we pass it through a pair of low and high pass filters. We apply an envelope, we pan it, we apply the envelope, and then we have an amplitude scaler and we send it out. And we are good and familiar with our friend the synth class. And we can create, basically instantiate a synth from the synth-def. So the basic structure of a routine is you create a new routine, as we've done down here. You will probably see me throughout this semester sometimes saying .new and sometimes not, and you can pretty much always omit it. And in this routine, just to recap, a routine is a function which has the ability to pause and resume partway through its program. So let's see, there's one thing we can do with routines is play them. And if we play this routine, we have not put any pauses inside of it. It's just sort of three synths, and when we play this routine, it will just attempt to evaluate it like a normal function. So we hear all 3 at the same time. But we can do stuff like this. And then play it. As a very simple but useful shortcut here, we can see that we're doing something very repetitive. And the only difference between these synths is the transposition value. So we can express this more concisely with iteration by saying -7, -5, 2, .do. Play the synth using an argument declared inside the iteration block, used as a semitone transposition converted to MIDI ratio. Just compare these side by side. Here we're explicitly putting in a number each time. Here we're automating the process to an extent by iterating over a collection of notes. The same deal? Yes, question?
Oh, I think I heard the answer, but the seconds is from the start of the file.
Your question is, these wait times, when do they occur? Yeah, so when we play a routine, it just begins immediately. And so it performs this action, which occupies virtually no time, like microsecond or something. And then it encounters this line and says, oh, okay, I'm going to wait for, well, technically it's 0.25 beats. But it's only beats because this routine is playing on a default clock, which runs at 60 beats per minute. So beats equals seconds. So in this particular case, we can think of this number as meaning seconds or beats at 60 beats per minute. So it waits for a quarter of a second. A quarter of a beat. Yes, in fact, these do overlap. It's not immediately obvious, but each of these synths is a totally independent entity. Synths can coexist on the server, and they can write to the same bus. They just sort of naturally sum. We can shorten this so that it's even more obvious. Right, all still sounding, just playing these files, just, play a synth, which results in the playback of a file, wait for a time, and then do the next one, and then wait, and do the next one, and wait. So these, and I think I mentioned last week that these wait times sometimes show up in help documents as yield instead of wait, and they are, I have yet to find a situation where yield works and wait doesn't, or vice versa. I'm sure one exists, but in practice, you can pretty much swap one for the other, so just don't feel like there's really a significant difference there. Although there probably is a slight one, but I don't think it's going to be relevant. All right, so this routine is finite. It performs an iteration block which results in 3 evaluations, and then there's nothing left. There's no mechanism here that says go back to the beginning or whatever, but we can reset a routine, which, think of this as like a reel of analog tape, and you're rewinding back to the beginning, and that lets you play it again. If we try to play it again, nothing happens, because there is nothing there. It's like evaluating an empty function, because it's sort of advanced and says, here I go, doing my thing 3 times, and then it's here. And when we say play, it says, what am I supposed to do? I got nothing. But we can always reset. And something to keep in mind is nested iteration. For example, let's say we want to do this 5 times. Something like this. Right, and then it's at the end. We can reset. We can also stop, which just ends the routine early. And I'm fairly certain that once you've stopped a routine, you can't actually resume it. I think it's just kind of gone. You've sort of like pulled the plug on it or something like that. And if we wanted the routine to do this forever, we have 2 syntactical choices. One thing we can do is say inf.do. Inf in this context will be interpreted as infinity, and so it's just, okay, I'm just going to do this forever. And in this case, we'll have to stop it at some point. If it's just going to go on forever. Right. Just does its thing until we stop it. When you put an infinite loop in a routine and play it, you must wait or yield somewhere. For preferably, if we run this code, comment this out and run it and play it, we're going to get the rainbow beach ball. It's going to mess up my video recording. You're basically asking the interpreter to run an infinite amount of code as fast as possible. And it sure tries, but it's doomed to fail. So this is, I've crashed the language many times, just messing around with routines, and then I play it, and then I don't hear anything, or maybe I do hear something, and then like a lot of synths all at once, and then nothing, and then I can't get SuperCollider to respond, and I have to force quit. And I think SuperCollider is pretty good about auto-saving these days, but this is like on par with the importance of knowing the command period shortcut. Always wait in an infinite loop when you're playing a routine. You just have to do it. All right, so let's see. So playing a routine is one thing we can do, but a routine is it is a subclass of a more general class called stream. And stream is the parent class of many useful sequence-based classes. And a stream is an object that represents a sequence of things which can sometimes be played, as in the case of routine, but all streams can respond or will respond to the next message, say, the routine.next. And when you call next on a routine instead of playing it, you can think of that as basically manually stepping through the routine. And each yield is a little checkpoint where the number dot yield, the number is irrelevant when you're nexting through a routine because it's just going to wait forever there. Let me show you an example. So if I create this routine, and then we call r.next, we get the first chunk from the beginning up until the first yield. And you'll notice that the value of the yield is returned to us. Now, in this case, we don't really care about that. We don't need to access the wait time, but there are other cases of routine where we actually do want to yield a specific value to be fed into some other process, and we'll get to that as well. But right now, I just want to demonstrate that when you say next, it just says, okay, start playing, and when you hit a yield, just stop. And then next, okay, keep going from where you left off, and then until you get to a yield, and stop there again. Question?
So if you have multiple yields inside of your do, it'll just do the first part, then the next part, then the next part, and then if it needs to go back, it goes back up again?
Yes. Every time the routine encounters a yield, it pauses until you say, okay, go ahead. So, I mean, it looks like we only have one yield here, but technically we have an infinite number of yields. Because what happens is we enter this infinite loop, and then inside the infinite loop, we enter a threefold iteration. And so we encounter this yield, right? We play a synth and encounter the yield, we pause. And then we encounter the next synth with a different transposition, and we wait. And then a third. And then after that three steps are done, the infinite loop repeats. So it's just, it doesn't matter if we have multiple yields, you know, written out. If we did this, then this would be a little bit different, because we'd say next, and now it's stopped at this yield. And when we say next, it's just going to immediately go here and hang out at this yield, and then it's going to go here. So every time it encounters a yield, it just stops. Make sense? Yeah. And we can reset, and now we're back at the original pitch. Right? Reset. And these are the two main ways of interacting with routines. Sometimes on routines we want to say, you know, I want your output on demand. It's like I will tell you when to advance through the next chunk. At other times we want to say, okay, just play, you're off on your own, do your thing autonomously. All right, and I mentioned that sometimes the values, I mean, the yields, when played, the yields are interpreted as durations to wait. But when nexted, they don't wait for a specific duration, instead they wait forever until we say continue. And when we next through a routine, it will return the receiver of the yield. And sometimes we care about that number and sometimes we don't. Here, we don't really. What we care about is the stuff that happens between the yields. This is a sound generating routine. So we're generating sound and maybe using this as a wait time if we want. So let me give you an example of a routine which doesn't actually generate sound, but allows us to construct some unique algorithm that isn't available in a single method, like, you know, rrand or xbrand. That's a perfectly good algorithm for generating random numbers. But let's say we want to start at a transposition of -12, add a random number between 1 and 6, and do that 8 times in a row, and then go back to the beginning and start at -12 and go up. Right? So this is something that's a little bit tricky to do without routines. We'd have to do some complex conditional logic or something like that. But routines make this pretty easy. So I'm going to call this note gen. And we will say, declare a variable called pitch, which is going to be -12 to start. And then say inf.do, pitch. No, I think, yeah, we'll say inf.do, and then 8.do. I'm gonna rearrange this as I go. Yield the pitch value, and add a random transposition. And what we need to do is move this in here. So let's walk through this. We have a routine with a variable that we can use inside of this routine. And then we are inside of an infinite loop, which says, okay, very first thing we're going to do is initialize pitch to be negative 12. Then we enter this inner iteration block, which does the following 8 times, yield the value of pitch, then add a random value to it. And we repeat that 8 times. So this routine doesn't really make sense to play. It would not make sense to play this routine because then the yield times would be interpreted as durations to rest, and the first one is negative 12. That's meaningless. You cannot rest for negative 12 beats unless you have a time machine, or I don't even know what that means. It's just nonsense. So although we could use the play method and see what happens, it's just, you're playing with fire, basically. We're designing this routine to be nexted, not played. And it looks like this. So here we'll just run it once, and we get negative 12 because we've entered the routine here, 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 yield. Okay, so we yield that value and we pause. And the routine is staying right at this moment until we say next. And then it goes and it's picked a random value of 5, and then it jumps back here and yields that value. And we can go, right? And that's 8 do's. So now we're going to exit the do, and we're at the end of an infinite loop, so we're going to come back up here, reinitialize pitch, and do it again. So now we have a quirky random number generator which has this 8-fold repetition, always starts at negative 12, and transposes each adjacent pair of notes somewhere between a semitone and a tritone. And there's lots of variations on this algorithm. You could, imagine, what if you want to do the same transposition between adjacent notes, but maybe do either 6, 8, or 12 notes. Lots of possibilities here. Really, we're getting into composition here, but we'll stick with this for now. Just like normal routines, this one can be reset. So if we are somewhere in the middle of one of these 8-fold cycles, we can reset, rewind back to the beginning, and we start at negative 12 again. Okay. So this is sort of the other main usage of routines. It's kind of a data sequence generator. Not a sound player, but just something which generates values for some custom algorithm on demand. And we can use these two in combination. Let's actually pull this down. So we have note gen, and we have we'll call this sound gen. And we're just going to say inf.do. And instead of n, we're going to say, actually, what would go here?
Notegen.next.
Yes, exactly, notegen.next. Yeah, so we define these two routines, and then, if we've done everything correctly, we should be able to say soundgen.play. It's kind of musical, right? I mean, it's kind of a content generator, right? It's like instead of having to sit there at the piano and use your brain, you use it for this instead, and then you say, okay, you make the notes. And you find one you really like, you hit stop, and then you write it down on staff paper. And so this is, taking a step back here, I think this is one of the most interesting and compelling uses of SuperCollider as a sort of second brain, a sort of algorithm system for generating musical material. And as soon as you find something you like, you shove it out of the way and get back to your staff paper or your notation software. And it's just whenever you need a break from your own musical thinking process, it can be really powerful. All right, so is that all making sense? Feeling okay? At least on a initial level here. Let's see, make sure I didn't forget anything here. Oh, okay, so let's move on now. And I want to address the fact that these yield times when we're playing a routine are, right now they're seconds, but that's only because we're playing it on a clock running at 60 beats per minute. So there's an object called TempoClock. And we can make our own tempo clock, but there actually is a default tempo clock whose tempo is 1. Now, it's not beats per minute, it's beats per second. It's a little bit, it'd be nice if it was beats per minute, but I think there's a lot of advantages to having a tempo clock running at beats per second. It's not a big deal, you just have to keep that in mind that the tempo of a tempo clock is beats per second. And this is the clock that routines run on when you play them and don't specify a clock. But let's make our own tempo clock. So we make a new tempo clock and we provide a tempo in beats per second. Give me your favorite tempo. 72? 72, okay, good. So how do we express 72 beats per minute in beats per second?
Divide.
Yes, divide by 60, right. 72 divided by 60. This 72 beats per minute, that means there's 1.2 beats per second. For example, like a simple, like 120 beats per minute, right? That's twice as fast, so it's 2 beats per second. Right? So just simple division. This is just, whenever you're making a tempo clock, you want to get in the habit of, I think most musicians are accustomed to beats per minute, so just divide by 60, you're good to go. All right, so we've made this clock, and it's actually running right now. And just to verify, we can ask the tempo clock, what is your current beat? And it's at beat 10.85, blah, 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 blah. I'm going to hold shift and return down, and you can see it's counting beats here at 72 beats per minute. If we press command period, I've pressed command period, that destroys any tempo clocks other than the default tempo clock. That one lives forever, I think. So sometimes we want this behavior. Sometimes we want a tempo clock to not survive command period, but other times we want it to survive command period, because if it's like a load-bearing tempo clock that manages lots of things, you don't want to have to go back and recreate it and do all this stuff again. So we can make a tempo clock permanent by setting its permanent attribute to be true. And so now we've created a clock and it's counting beats again. And if we press command period, it's A-OK. So now this is a command period immune clock. All right, so okay, let me first show how to schedule arbitrary code. Oh, question?
Yeah, what is the underscore thing?
The underscore is a syntax that is called setting. There's lots of situations in SuperCollider, in graphical user interface design in particular. Every slider has a lot of attributes like background color and this and that. Sometimes you want to get those attributes. Sometimes you want to set those attributes. So if you have some object with an attribute, this expression gets, like say color or something, right? The color of the object. And this sets the attribute to something. So this is getting and setting. It's a pretty fundamental thing. You find it in lots of different programming languages, right? Especially in object-oriented languages where objects have all of these, variables stored in them. I call them attributes. I don't know if that's what most people call them, but you get the idea. So we're setting the permanent attribute of this tempo clock to be true, which makes it survive command period. All right. So it's tempo clock is still counting away, right? We're at beat 105 or so. There are 2 scheduling methods. We'll connect this with routines in just a second, but I just want to introduce these 2 very simple methods. So t.sched is a relative scheduling method. You provide 2 things: a duration measured in beats from now, and a function to be evaluated that many beats in the future. So we'll say for hi. Okay, so we say, when I run this code, schedule the following function to be evaluated 4 beats from now. There you go. Okay, so this is relative scheduling. There is also sched abs. This is absolute scheduling. It wants an absolute beat value. And right now I'm just kind of guessing. We can check the beats and try to anticipate. So we'll say 190. Wait for it. There it is. So that occurred on beat 190. You might do things like next bar. This gives us the default number of beats per bar is 4. So whenever I run this, it sort of figures out its current beat and compares it against its beats per bar that is stored here. And it just says, okay, what's the beat number of the next cluster of 4 beats, the next downbeat, basically. So this is a way of saying, do this on the next downbeat. Schedule this function on the next bar. And that's basically it. All right. One thing that's kind of initially frustrating about TempoClock is that there's no visual metronome, right? We can't see the beats, but it's not too much work to get SuperCollider to print the beats as it goes, just so you can use the post window as a very crude but effective metronome. So let's stop this TempoClock and just kind of start over here. All right, so we'll make another TempoClock and see if I can do this off the top of my head. So we're going to make a post info function that says t.beats.postln. This is going to be the function that gets scheduled on the clock. And then we're going to say t.schedule, we'll just say t.schedule. Well, actually, we're going to move this in here. So scheduled, I think this will work. Just schedule on beat 0. Post info. Evaluate. Now, okay, we could do this. We could just put the function right here, but I'm going to do it this way, a function within a function for a specific reason. Now what this is going to do is just post the first beat. Oh, I crashed it. I think I crashed it. Oh, I crashed it. Okay. I knew I was going to crash it. All right, let's see the damage. I think it saved everything, so try to be a little more careful this time. Yeah. Okay. All right. All right, so something I probably should have mentioned first. I probably should have done this first, but if you schedule a function on a tempo clock and it returns a number, like this one does, then this function will be rescheduled that many beats later. So it's a way to get a function to happen over and over and over again. Okay, so that's going, and we'll just say schedule it right now, and there we go. So it schedules it kind of immediately, and it posts the string high, and then waits for 1 beat, and then schedules it again. And there's no good way to unschedule this the way we've done it. So I'm just going to hit command period. and stop the clock. Oh, I command period stop the clock, but that's okay. So here, what we want to do is put a 1 here. Okay, so we have this function which posts the number of beats and then returns the number 1, which in the context of a tempo clock makes it reschedule every 1 beat. And here's our permanent clock, and then we say, hopefully this will work. And I am missing a parenthesis over here. There we go. That is what I meant to do. Right. And the benefit of this approach of evaluating a function within a function means that we can redefine this function on the fly. So if we go here and we say, you're now empty, it unschedules this function because suddenly it's evaluating this function which has nothing in it. So nothing happens and it doesn't return a number, so no more function stuff. And if we want to bring this back, we would take this and this, I believe, because the tempo clock is still going. And we didn't stop the clock, we just unscheduled that function from it. So if we reschedule it, okay, so I didn't quite do that right because I made it start counting immediately. So I'll answer your question in just a second. Let me unschedule this again. And what we want to say is tsched abs t.next bar or something like that. And there we go. Now we're back on track. So this cluster of stuff right here is, something to take a little snapshot of and save it in a file, because whenever you're working with routines and clocks and timing and things like that, it can be very helpful to have just the post window counting beats, just so you can sort of see what's going on and verify that things are coming in at the right beat. Question?
Doesn't that mean in line, I guess 3?
Oh, sorry, this one?
No, 115.
115, yeah.
Aren't you creating a new tempo clock every single time, or is it just reallocating it to T?
If I were to run this multiple times, yes, I would be creating another clock named T. So we have multiple clocks going, but T only refers to the most recent one. But I'm not running this clump multiple times. I'm running this to unschedule and this to reschedule. So this is sort of our initial creation code. This is when we want to stop seeing beats, and this is when we want to resume seeing beats. That's a good observation. Yeah, you generally, don't need to create multiple instances of clocks running at the same tempo. It's just redundant, right? I don't think they take up too many resources. I think it's just sort of simple timing stuff. But okay, let's get back to routines. And I want to show how routines intersect with tempo clocks. So let's go and grab this pair of routines. And we've already got a clock running, so we can just jump on it. So this is our note generation routine. It's not really meant to be played or quantized or locked onto a grid or anything like that. It's just an on-demand semitone transposition generator. But this one here is the one we want to play on this clock, because the yield time is 0.25. And remember, this number ultimately means number of beats. And okay, so we run this, and then if we want to say soundgen.play, if we run this, it's going to go on the default tempo clock, and it's going to play and wait for a quarter of a second. But with routines, it takes two arguments, clock and quant. We'll just deal with clock for now, and very, very simple. You just say, that's your clock, clock T. So now if we play this, you will hear the notes come sort of four notes for every one of these values. It's not going to be synchronized to the downbeat, but just we'll let it play for a second. Why is it so loud? What happened? No. Why so loud? Something is a miss. Oh, okay, this is outside of the arrays. But it wasn't allowed earlier, so I am a little mystified. Okay, I have to make my clock again. I hit command period or something, so make that. All right, so you can hear 4 notes per beat, right? So let's just change the tempo of the clock. So watch the numbers. All right, now we're at 108 beats per minute. Okay, so it's just proof that it is in fact following the tempo information of the clock on which it runs. Okay, so how do we quantize it? We want this to come in on a beat that's a multiple of 4. Well, we provide the quant information. And let's reset this. And let's say 8, for instance. So this is going to come in on the next beat multiple of 8. Basically, it's going to look at sort of from time 0, and it's got all of these 4 beats per bar, and it's going to come in on the next downbeat of a pair of 2 bars. So let's see if I can, I'll hit this right after beat 160, and it should come in on 168. Right, and that is quantizing. There's a little bit more detail to quant, like you can set quantization division, like every 4 beats, every 8 beats, whatever, and then you can shift it forward and back by 1 beat. I think that involves, well, you know what? I'm going to look up the help file because I'm not sure. Yeah, it's got 3 items here: quant, phase, and timing offset. Yeah, so I believe quant is just the sort of raw quantization value, like the beat multiple. Phase will shift it forward or backwards by a certain number of beats. And then timing offset is, I think, just a raw value in seconds if you need to nudge it by, a fraction of a second in either direction or something like that. So I think if we provide an array, something like this, let's do 4. So I believe this will come in on the next beat multiple of 4 plus 1. It's either plus 1 or minus 1. I get these confused. So I'll try to land this on 324. Or, yeah, 325. So this is a way of still dealing with a grid which is 4 beats, 4 beats, 4 beats, but you can push it ahead to whatever beat comes next on one of those. And -1 will play it on the, beat 4, basically, of the next measure. So that would be, here it's going to come in on 363. Maybe not. Oh, I have to reset the routine. Yeah. So 384 was the next quantized beat, and we had a phase of -1, so it comes in on beat 383. All right. It feels like a pretty okay place to stop. I don't want to get too deep into it, but another thing I wanted to discuss, and we probably will next week, is nested routines. You can make routines that represent phrases, and then you can kind of compose with them in a larger routine. And build outwards with these composite routines, and you can make routines play in parallel, so they basically play simultaneously, or in series. You can have a sort of a composite routine with like 4 finite routines, and you can have this one go, and then this one go, and then this one go, and then this one go. And from there, we're going to transition into a large family of objects called patterns, which are one of the most celebrated features of SuperCollider. It's a pretty unique library. They're little prepackaged algorithms for generating data that makes things like this, generating sort of specific, data output, very trivial. I mean, each one's got its own unique flavor and its unique task that it's responsible for. So, just sort of a looking forward to what's to come. Question?
You said the tempo clock mid routine.
Yeah, you can. A pretty common. You can set the tempo clock. You can set the tempo clock's tempo mid routine. You can set it at any point in time, and a fairly common thing to do is schedule tempo changes on specific beats of a tempo clock, using this strategy right here. You say schedule on beat 160 instead of post info. You would say p.tempo equals our new tempo. Right? So this means on the next bar, change the tempo. Yeah, you can schedule any valid code on a beat, right? It's just schedule, do this thing, evaluate this code on this beat or this many beats from now. So yes, absolutely. Right, you can change the number of beats per bar on a particular beat. The tempo clock help file is pretty good. It's in terms of documentation, it gives you all of these clear tempo, beats to seconds, seconds to beats, beats per bar. And they're pretty easy to just test. You can just make a clock and start calling these methods and see what comes out. And it's weird if you're used to DAWs where it's like I have a timeline and I can see everything and I can drag things around. It's the same idea. It's just a lot of it is kind of concealed and it's behind a code interface. So it takes a little getting used to. Okay, I think I'll start working on a sequencing-based homework assignment, but it won't be due for at least 2 weeks. Midterms coming up next week, so I wouldn't focus your attention on that, and might even take me a few days to get to it. But anyway, so I guess that's it. Stick around if you got questions, and see you next week.